Okay, so we're going to be using special triangles. One thing we're going to do is these triangles are going to become pretty important for finding exact values. And when we're talking about exact values, it means we're going to be putting things into fractions. So we talked a little before about setting up maybe if we had a sine ratio of 45, how that would be 1 over root 2. That would be considered the exact value. We wouldn't actually evaluate that root and divide it by 1. We want to leave our answers that way. So, for instance, they may give you a question, which I think they have here, something that says find the exact value of sine 45 multiplied by cos 45 plus sine 30 multiplied by sine 60. Okay. Well, one thing you could do is you could obviously just go into your calculator and evaluate all of these, and maybe we'll actually do that really quickly and then show how the exact value is technically more accurate. If we had 45 sine multiplied, this calculator is not so great for doing full things in one shot, multiplied by 45 cos equals 0.5. Oh, actually this one's going to give us a great answer. Okay, so we know that these two are 0.5. And then we set up sine 30 multiplied by sine 60. Okay, so 0.433, 0.433, and when we add those together, it looks like we're going to have roughly 0.93 something. Okay, assuming that calculator did everything right. Well, what we can do here is we're going to actually work with our fractions, and we got to remember our fraction rules when going through this. So the special triangles they're going to expect us to have memorized. So we're going to have to remember these as we go through. We have them on top for now. Sine 45. Well, sine 45 can refer to either of these angles in the first triangle we're dealing with, right? So sine 45, I'm going to put a number 1 there so we know when I refer to them which ones we're talking about. In the first triangle, sine 45 is going to be opposite over our hypotenuse, right? Which means we can replace sine 45 with a fraction, our fraction being 1 over root 2. Okay? Cos 45. We're going to work on the same triangle again, right? But again, it doesn't matter which angle we work with, we're still going to end up with the exact same ratios we did before because it's in isosceles triangle. So our cos 45 can be replaced with 1 over root 2. Exactly. Sine 30, well, that's when we have to go into our second triangle. And now sometimes the second triangle can be hard to remember how to draw. But think of the angles. We always know our 90, right? Our 90 degrees is the opposite of that side, always going to be the longest side. Okay. Well, it can be tough to remember, is one opposite of the 60 degrees or is one opposite of the 30 degrees when drawing it out. A good way to remember is technically we know, if we remember the values around the side of the triangle, we know root 3 is a larger number than 1 is, right? Well, think of this like a mouth opening. If a mouth is opening 60 degrees, that's a larger opening than a mouth that would be opening 30 degrees. So whatever's opposite of the 60 degrees must be the larger side in comparison to the 30 degrees. Does that make sense?
Yeah.
Okay, so then let's talk about sine. Sine 30, well, that again is our opposite over our hypotenuse, and in this case we're just going to have 1 over 2. Now we could write it as 0.5, but it'll go a lot easier for us when evaluating an exact value if we leave things in fraction form. And sine 60 is still going to be our opposite over our hypotenuse, which is going to give us root 3 over 2. Okay. From here we're going to multiply fractions. Do you remember your multiplication rules for fractions? Bottom by the bottom, top by the top. Great. Okay. Well, 1 by 1 is going to be 1. Root 2 times root 2 will give you what?
Root 4.
Think of it like this. We're multiplying whatever those roots are, right? So it might be easier to show in something like a calculator, or actually let's think of an easy example. I'm going to go a little example on the side here. Let's say we're multiplying root 4 times root 4. Well, what is the root of 4?
2.
2. So it becomes 2 times 2, which is what? 4. In other words, if you remember exponent rules at all, we're multiplying bases that are the same, right? Both of our bases are the same, 2 and 2. And you can represent a root as an exponent. Have they showed you this yet? So it's 2 to the half. Yes, right? So if we're multiplying two exponents with the same base, we add the exponents together, and what are we going to get? 2 to the power of 1. In other words, we really just need to keep the base. So it's going to be 1 over 2, which is exactly we found when we put in our calculator, 0.5. Okay. On the other side, 1 times root 3 is still going to be root 3, and 2 by 2 is going to be 4. Now we got to go fraction rules for adding. What do we have to find here?
Common denominator.
Exactly. So we're going to make this a common denominator. We're going to multiply the top and the bottom of this fraction by the value of 2, so our denominators are the same. Now that our denominators are the same, actually we'll do this one step at a time so don't get confused. 2 over 4 plus root 3 over 4. Well, the denominators are the same. I don't actually have to write them separate anymore. I can write this as one whole fraction, right? All of it above the value of 4, and we're left with 2 plus root 3. Okay? And that is essentially our exact value. We can't go any farther without getting a run-on number, mainly because root 3, when we find the square root of it, is going to be a never-ending decimal, right? So that should be our exact value. Yeah, that's what they end up with there. Okay, so that's what they mean by finding exact values using these special triangles. We're going to use their primary trig ratios to get a fraction answer in the end. Does that make sense? Yeah.